Before we start rendering, we have to solve one more problem. Let's take a look at reference. You can see that in the first frame, the body has white material. And when the bubble starts to appear, they have completely different material. So we need to use different materials on the same mesh. But the problem is we use volume builder and volume mesher, and topology changes every frame. That means that we cannot use UVs to project textures. So we have to find some way to create a mask which we will use to blend different materials. Let me show you what we're gonna do. Select volume mesher and create vertex map tag. Vertex map stores additional points information. And to control this information, we're gonna use fields. For instance, if I create a linear field, red areas will have value 0 and yellows will have 1. We can use this information to create a black and white mask, which we will use to mix two different materials. The simplest thing we can do is just use linear field and paint it so that the top is black and the bottom is white. I think it is too boring. I want to emphasize the shape of the bubbles. So for now, I'll remove linear field. And you can use not only fields, but also geometry. For instance, we can use the bubbles themselves. It doesn't work with nulls, and to make it work, we need to convert it to geometry. But I also don't want to convert it inside volume builder, so we're gonna use instance. So at first, let's create instance of bubbles, and to make it work with vertex map tag, we need to create connect object. Just select an instance, hold down Alt, and create connect. I'll rename it to bubble mask. Let's keep it organized, so create a null and call it masks. In this null, I'm gonna store all fields and objects for vertex map tag. Then place it inside null called body, right next to original snots. And now we can use it as a field. Just select vertex map tag, then drag and drop bubble mask into fields list. You can see spheres intersect the volume measure. If I disable it for a moment, this is actually bubble mask, so let's just make it invisible. Now, if you select the vertex map tag, you will see how the geometry of the spheres masks the points that are next to it. You can adjust the radius, try to experiment with different modes, such as point, surface, or volume. I'll tweak it just a little bit. It looks fine already. We have some mask on bubbles, but we also need to mask snots. And in this case, it will be easier to use linear field. Let's just create it and place inside masks. And make sure it's in a list of vertex map tag. Let's adjust its orientation and position. I'll just move it approximately in the middle of the bubbles so that it masks everything below. I got something like this. And now we need to animate these masks so that they appear not in the first frame, but when the bubbles appear. And the easiest way is to use already existing linear field, the one we used for animation of appearance of the bubbles. Let's find it. Inside the bubbles null, we have activate bubbles, and it has shader and linear field. As you remember, the linear field is animated and moves from left to right. So let's use it. Just select vertex map tag, then drop linear field inside. Switch blending mode to subtract. Looks nice, and when the marshmallow starts to scream, we can animate the first linear field. I want to smooth the transition between two materials to emphasize the melting effect. You can find it in mask nulls. And in this frame, I'm gonna move it up and expand a little. Nothing complicated. I'm just creating two keyframes and animating the Y position and the length of the field. You probably noticed every time you hit play, the shape of the snots looks a bit different. This is because of some simulation we used in track modifier tags. So before we start rendering, we need to bake the entire animation. On this stage, you can check everything you made, maybe fix something, and when you're happy with everything, save the project, and we're gonna bake the marshmallow to alembic. For that, just select Volume Measure, right-click and select Bake as Alembic. It can take some time. You should get the Volume Measure Alembic object, and you can delete everything except this object inside the body now. It is recorded into one file as a single mesh, and it works very fast. Another advantage is that it stores vertex map tags. From this moment, we lost the ability to adjust the animation, so please save it as a new project. Also, you can find the alembic itself in this path. Now we can start rendering. Go to Redshift menu, run Redshift Render View, and hit Start button. Now let's create the first light. I'm gonna use Area Light. It works the same as Softbox in Real Photo Studio. I'll change its area shape to disk and then adjust its location. It will represent some kind of moonlight sky in a dark wood. In Attributes, I'll drop down the intensity a bit and then scale it up a little to make it softer. Next, I'll duplicate it while holding down Ctrl Command on Mac, then move it back and a bit left to make some backlight. Then bring back intensity a little. It is not very obvious, but you can see it later reflecting off snots. I also want to illuminate it from the right side, so I'll duplicate it again, then adjust the scale and intensity. The idea was that the marshmallow is fried on the fire, so I'll duplicate it again and move it down. In Attributes, I'll give it yellow-orange color and then make it a little brighter. And to keep it clear, let's rename all sources. We don't need reference plane anymore, so let's remove it and let's create some materials. Hit Create Redshift Material Standard. Then right away drag and drop onto marshmallow body. Double-click on Material to reveal the node editor. The node editor is pretty similar to Espresso. Now we have only standard material connected to output. So select the node and pick some light marshmallow color. I'll make it a little yellow. The real-life marshmallow has very pronounced subsurface scattering effect. In standard material, you can just scroll down and find Subsurface tab. I'll just increase the weight and give it slightly yellowish color. It looks too glossy for the marshmallow, so let's adjust the roughness. Now when we created the first material, I want to adjust the lights a little more. I just want to make it less intensive. To make material for the lips and the eyelids, I'll just duplicate the marshmallow material. Then I'm going to adjust the subsurface color. I'll select some pink color. And then you can drag it and drop directly in the viewport. I want to make it glossier, so I'll decrease the roughness. And then adjust the subsurface color a bit more. Just a little lighter. Then duplicate it once again and make it material for the eyes and the teeth. For now, I'll make it yellow just to distinguish it from marshmallow material. We cannot drag it and drop directly because it is Connect object. You need to apply it to the spheres. So I'll do it in the Object Manager, and I'll do the same for the teeth. And then adjust the color a bit. After that, I'll duplicate the pink material and I'm gonna apply it to the tongue. Nothing special here, just pick some violet color. I noticed some hard edges on the tongue, so let's subdivide everything at once. Just select Pivot Null and create a Retrieved Object tag. In Geometry tab, hit Override, Enable, then set maximum subdivisions to 2. It works like subdivision surface but in render time. I'll adjust the tongue material a bit more. In particular, I want to make it rougher. Maybe a bit colder. Also think it scatters light too much, so I'll decrease the subsurface scale a bit. I also want to create a material for this black plate. I want to make sure that it doesn't receive any lights, has no reflections, and it's completely black. So I'll pick the black color and set reflection weight to 0. We can also adjust the iris and pupil materials. I'll just make the pupil darker. Now let's create a material for the bubbles. Find marshmallow material, then double-click to reveal the node editor. At first, let's just duplicate this node and connect it to output. Go to Subsurface tab and pick some pink color. I want to make it glossy as it melts, so I'll decrease roughness. And next we're gonna add some bumps. I will use normal map, so just drag and drop it here. While hovering above node editor, hit C and type bump map. In Redshift you need this node if you want to use bump textures. Just connect it to the input and the output to the bump map input of the material. Then select texture, and to make it work correct we need to select the right color space. For normal maps always use raw. Then select Bump Map node and set map type to tangent space normal. Now everything is correct. Let's see what we have with the UV coordinates. Now select the material tag of the body. The projection is UV mapping. It means it uses UVs generated by a volume measure. It looks not very good, so let's try something different. Cubic looks okay for me. So let's tweak the material a little more. I'll select the bump node and decrease the height a bit. I just want to make it less pronounced, just small details and reflections. And then adjust other parameters just a little bit. Decrease the roughness. I want to make nodes more transparent, so I'll increase the subsurface scale a bit. I'm okay with this material, so let's tweak the first material. Just connect it to output. This time I'm gonna use some noise for bump, so hit C and find max on noise. If you want, you can connect it directly to output to see it in render view. I'll set type to Voronoi 1 and then switch colors to make bumps white. I want to add some contrast, so I'll go to Output tab and adjust high and low clip. To make it smaller, you can go to Input tab and decrease scale. Now let's connect the material to output. I'll duplicate bump map node, but this time I'll set it to height field. This way we tell the Redshift we use black and white map. Now let's connect everything and see how it looks. I want to scale it down a bit more. I also want to decrease the intensity, So I'll go to bump map node and decrease the height to 1.5. When both materials are ready, hit C and find a material blender. Now connect it to output, then first material connect to color and second to material color. And to third input, we're going to connect the black and white map, which we will use to blend two materials. For instance, we can connect black and white noise or any other black and white shader or texture. But this time I want to use vertex map tag. To do so, hit C and find vertex attribute. Let's immediately connect it to blend color. Then find vertex map tag in Object Manager and drop it into attribute name. Let's see how it looks in different frames. In my case, everything looks great, but if you want, you can modify it using ramp node. Just hit C and find ramp. Then connect vertex attribute to alt input, and then connect the ramp node to output. You can adjust this gradient to remap the black and white values. For instance, you can make it sharper. Let's see how it looks with Material Blender. I love the original one, so I'll leave it like this. Now let's create a background. For this, create a plane and make it a child of the camera. Then in Coordinates tab, zero out all the coordinates. In Object tab, switch the axis so that it's perpendicular to the camera. Then move it along Z-axis behind the scene. And in Camera View, manually adjust the proportions. After you adjust the plane, create new material. I'm going to create standard redshift material and drag and drop it onto plane. I prepared animated backplate. Just drop the first frame into Node Editor. Then connect it directly to output, and we don't need the material node, so you can remove it. The colors are incorrect for now. To fix this, we need to set the right color space. Redshift uses aces, so we need to invert aces. Now colors are correct, and we need to enable animation. Go to Animation tab, set mode to Simple. We use 12 frames per second, and then hit Detect Frames. Scroll the time slider to make sure it works. And now, when we have backplate, I want to fix something. The shadows looks too dark, so I'm gonna create another light source, and this time dome light. It just evenly illuminates the scene from all sides. I'll just fix intensity, make it a bit smaller. Marshmallow is a very tiny object, and we can make it much more realistic if we add some depth of field effect. For this, select Camera and enable bokeh. To make effect more noticeable, we need to greatly reduce the aperture. Also, we need to correct the focus distance. You can make it manually right here, or you can use this dropper and pick the point in viewport. I'll maybe increase the aperture back. Let's see how it looks in different frames. And the last thing that we'll have to do is the texture of the stick. I'll create another standard redshift material, then find the stick in Object Manager and apply the material. I'm not going to do anything complicated. I'll just drop this texture and connect it to color. I want to make it more matte, so I'll increase roughness. We made it out of a cylinder, so it has cylindrical UVs. Let's keep it simple. Just choose any projection that looks okay to you. I'll use cubic projection and then adjust it a little in texture mode. Now let's see how everything looks in different frames. If you're happy with the result, let's make a test render. For this, just switch to bucket rendering. At first, I just want to render one frame. This video sped up 4 times and you can see it renders too slow, so I'll see how it looks and then adjust some settings. The final result is pretty good, so let's go to render settings. In output, you can change the resolution. I'll leave it like this. Then don't forget to set the frame rate to match the project. In our case, it's 12. Set frame range to all frames from 0 to 55. In Save tab, select the path in which you want to save the animation. I'll set format to PNG, and in Redshift tab, I'll slightly change the settings. You can use standard presets, but I use medium and it renders too slow. That is why I'll switch mode to advanced. In Global Illumination tab, I'll set secondary to brute force. We use limited frame rate, so I'll disable the motion blur. In sampling, I'll set threshold to 0.05 and enable denoise. Now let's make another test render. Now it renders much faster. The only thing is that because of denoise we lost a few details. I'll save the project just in case. Then hit Render to Picture Viewer. If the couple of frames are ready, check if they appear in a folder, and if everything is okay, just complete the render, and you can combine those frames in any video editor such as After Effects or Premiere, and this is my result.